All right, so get this. We're diving into the future where robots are mining asteroids for us.
Full-on space mining.
Not just sci-fi anymore. You ready to unpack this?
Let's do it.
We've got excerpts from some pretty serious research. Automation and robotics in asteroid mining operations. It's a mouthful.
Yeah, but we'll break it down.
No jargon here, just the good stuff.
The mind-blowing core ideas.
Okay, first the big question. Why robots? Why not just send people out there to mine these asteroids?
Well, sending humans to asteroids. Think about it. Extreme temperatures, radiation exposure is a really dangerous scenario.
It's not exactly a walk in the park.
Not at all. And then you've got the financial side, life support systems, emergency protocols millions of miles away. It's incredibly expensive.
So it's not just the technical challenges.
No.
It's the cost and the risk to human life, too.
Absolutely. Robots, they kind of eliminate a lot of that risk. They can operate 24/7 in those harsh environments. They don't need food or sleep.
Right.
And they're way more precise with their movements. Plus, if a robot breaks down, it's a technical issue, not a human tragedy.
That makes sense. So when we talk about robots, we're not talking about like one single robot doing everything right.
Oh, definitely not. Think of it like a specialized team. Each robot with a specific job, like a well-oiled machine. You've got your exploration robots, like NASA's near Shoemaker. They're the scouts, mapping the asteroid.
Map it out.
Yeah, using LiDAR. It's like 3D laser scanning and hyperspectral imaging, which analyzes the light to figure out what the asteroid is made of.
So they're giving us the blueprint.
Exactly. Crucial data for the next team.
Yeah.
The excavation robots.
Yeah.
These are the heavy lifters, equipped with drills, scoops.
The big guns.
Yeah. And specialized tech, like NASA's RASR stands for Regolith Advanced Surface Systems Operations Robot.
Get you.
Their job is to get that regolith out.
That's a loose...
rocky surface material.
Okay, got it. So after they excavate,
Yeah.
what happens to all that regolith?
That's where the processing robots come in. Imagine them as a mobile refinery, right there on the asteroid. They use magnets to separate out metals or electrostatic separation using electrical charges. It's how they get the valuable elements out.
It's like a sorting system in space.
Exact.
So we got the good stuff separated out. How do we get it back to Earth?
You're thinking about the transport robots, the logistics crew. They move the processed materials to storage or even load them onto spacecraft.
Wow, a whole automated assembly line. Millions of miles away. But what about the robots themselves? Are we talking like clunky machines or cutting-edge tech?
This is cutting-edge stuff. Mind-blowing technology. Multifunctional grippers, for example. Imagine a robotic hand that can mold itself to any shape, grabbing onto those irregular asteroid surfaces.
Wow, so no more limitations from like traditional robotic arms.
Nope. And think about how robots move in low-gravity legged robots, wheeled or tracked robots, even hopping robots.
Hold on, hopping robots. That sounds like something out of a movie.
They use the low gravity to their advantage, moving efficiently across the surface.
Yeah. It's incredible.
Yeah,
But we can't be controlling these robots manually from Earth, can we?
you're right. That wouldn't work. Millions of miles, the delays. That's where AI steps in, artificial intelligence. A total game changer.
Okay, AI in space mining. This is where it gets really interesting.
AI is the brains of the operation. It allows these robots to be incredibly efficient and self-sufficient, even with the communication delays.
So how does it actually work? Give me the specifics.
Machine learning is key. The AI analyzes data from the exploration robots to figure out the best mining strategy. The robots are learning and adapting based on the data they're getting.
So they're making decisions on the fly.
Exactly. And it gets even cooler. Predictive maintenance. They've got sensors that monitor wear and tear.
Okay.
The AI can then predict when maintenance is needed, preventing breakdowns before they happen.
Like a self-tuning car.
Basically. And then you've got swarm intelligence. Imagine a bunch of robots working together like a hive mind. They communicate, coordinate, adjust their actions based on what the others are doing.
So the dynamic team.
Right. Resilience efficiency. They can tackle challenges that a single robot couldn't handle.
It's amazing. It
Yeah.
sounds like we've got this all figured out. But I'm guessing it's not all smooth sailing, is it?
Space is tough. Making sure this technology works reliably is a huge challenge.
What are the scientists working on right now?
Well, reliability is a big one. These robots need to operate perfectly in extreme conditions for years at a time. Temperatures, radiation, or microgravity.
Yeah, it's a hostile environment out there.
And it's not just the hardware. The software has to be tough, too. These robots need to make decisions in real time.
Oh, yeah, millions of miles away from health.
Exactly. So the AI has to be adaptable, Handle unexpected situations, make the right call without human intervention.
High stakes for the software developers.
For sure. And then there's the power issue.
Yeah, keeping them running.
You can't just plug them in out there. We need efficient energy sources, lightweight enough to launch into space.
So it's a balancing act.
Power versus weight. Always a challenge in space.
Okay, so this is all super cool, but why should the listener care? What's the big picture here?
Aside from the tech, asteroid mining could change everything about how we think about resources, about space exploration in general.
Okay, I'm listening.
Imagine we're not limited by Earth's resources anymore. Asteroids are like treasure chests, full of valuable materials, metals, water ice that can be turned into fuel, even platinum group metals, essential for all sorts of advanced technologies.
But we're talking about a whole new era.
Exactly. Yeah. Building space habitats, fueling spacecraft, even 3D printing in space, all powered by asteroid mining.
We could build anything. Space stations, lunar bases, colonies on Mars.
The possibilities are endless.
It's mind-blowing.
Yeah.
But I have to ask, what about the implications? Who owns these asteroids? Do we just go out there and take what we want?
You've hit on a crucial point. As this technology gets better, we need to have serious conversations about the ethics of all this.
The legal side of things, too.
Right. The Outer Space Treaty was written way back in 1967, long before asteroid mining was a real thing.
So it needs an update.
Definitely. We need to figure out who has the right to mine these asteroids, how to share any profits. Because let's face it, this will involve private companies. And how to make sure it's all done sustainably.
So many questions. Do we treat asteroids like international waters? Do we divide them up? How do we protect the space environment?
It's complicated. No easy answers. We need global cooperation, scientific expertise, and a commitment to finding solutions that benefit everyone, not just a few.
This is where it gets really interesting. It's not just about the robots. It's about what kind of future we want to create out there.
I agree. It's a huge responsibility, but also a fantastic opportunity to think critically, act ethically, and work together on a global scale.
A lot to think about.
Right.
But are there any actual missions happening right now? Stuff that gives us a glimpse of this future?
Absolutely. Several missions that show the potential of robotic asteroid mining.
Give me some examples.
Well, there's OSIRIS-REx, an NASA mission that grabbed a sample from asteroid Bennu back in 2020 using a robotic arm. A huge achievement. It gave us valuable data and proved we can interact with these asteroids in a very precise way.
So we've already brought back pieces of asteroids.
We have. And then there's RASER, the regolith excavation robot we talked about, designed for the moon. But the tech could be used on asteroids, too. And there's the European Space Agency's Hera mission studying the Didymos binary asteroid system.
Didymos? What's special about it?
Back in 2022, NASA crashed a spacecraft into the smaller asteroid in the Didymos system intentionally. It was a planetary defense test. The Hera mission is following up on that, using drones to study the crater and gather data.
So it's an international effort using cutting-edge tech to study asteroids and maybe even learn how to deflect them.
It's like science fiction come to life, but it shows what we can do. Human ingenuity, our drive to explore the universe. And as technology improves, who knows what we'll be able to achieve.
It's incredible. So much to process. My brain needs a break. We'll be back in a bit to talk about the impact of all this and those ethical questions we touched on. Stay with us. Okay, we're back, and I'm still thinking about those robots hopping around on asteroids.
It's quite the image.
Mining all that valuable stuff, maybe even helping us build a future in space. But we kind of skimmed over the ethical questions, didn't we?
Yeah, we did.
What are some of the biggest concerns people have about all this?
Well, one big one is the environment. We're talking about potentially massive mining operations. What's that going to do to those asteroids?
Right.
And to space itself?
We don't want to create a cosmic wasteland.
Exactly. And then there's the question of who owns these asteroids anyway?
Yeah.
Is it like the ocean, open to everyone?
First come, first served.
Or do we divide them up somehow? And how do we make sure everyone benefits, not just a few companies?
Tough questions. Sounds like we need some new rules for space.
Definitely. The old treaties weren't written with this in mind. Asteroid mining wasn't even on the radar back then.
So we have to adapt
to a new reality. Think about environmental protection, resource allocation, profit sharing, conflict resolution, all in the context of space.
It's a whole new world.
It is a challenge, but one we have to face.
It feels like asteroid mining is about more than just robots and tech.
It is. It's about humanity's role in space, about what we do out there.
It's a big responsibility.
It is, but also an incredible opportunity. A story about human ambition and exploration, but also about responsibility, making sure we do things right for a sustainable future.
Wow, that's a powerful thought. Thanks for taking us on this deep dive into asteroid mining.
My pleasure.
It's been fascinating. And for our listeners, this is just the start. The future of space is unfolding right now. Keep learning, keep exploring, and maybe you'll be part of this incredible story.
You never know.
So that's it for this deep dive. Thanks for joining us. Until next time, keep looking up.